In the world where the impact of human activities on the environment is more evident than ever, the need for responsible and eco-conscious practices has never been greater. I am Siti, and bear with me for a couple of minutes, and my team and I shall show you the revolutionary framework that will guide us towards creating a more sustainable and environmentally friendly future together, which is the 12 principles of green chemistry. Let's uncover it together.
Hi guys, I'm Ong Kai Boon. I'll be sharing with you about the characteristics of our deodorant product that fulfill the first green chemistry, which is prevent waste. First of all, our packaging implements the concept of behavioral packaging concept, which is a type of packaging that triggers sustainable and virtuous behaviors in our customer. Our deodorant tubes also made from paper boards and fully recyclable. Our packaging actually is made from plantable wildflower seeds plants. Besides that, our product also made from biodegradable labels printed with soy ink, which is primarily composed of triglyceride. Apart from that, the green dyes from our products is extracted from the mints and it is biodegradable. Last but not least, our company is a certified B Corps, which we will donating 2% of our sales annually to the tree planting campaign. That's all from me for the green principle number one.
Now, teacher, I'm JJ and I will be presenting about the second principle, which is maximizing atom economy. Maximizing atom economy is about the more efficient use of reactant. Considering atom economy, which is the first one, reduce waste production, meaning that more efficient use of reactant, reduce cost of waste management, and the second, lower cost of production, less material needed as a starting product, and the third one, reduce environmental impact, which is reduce waste, fewer hazardous byproduct.
Hi guys, I'm Tanjingler. I'll be talking about green chemistry principle number 3, which is less hazardous chemical synthesis. This principle is about using and generating substance with minimum toxicity and environmental hazard. To synthesis glycerol, which is used to neutralize odor in deodorant, ethanol is used as a solvent instead of benzene. This is because ethanol is a renewable resource, biodegradable, low toxicity, and versatile solvent. Unlike benzene, ethanol is readily available and doesn't pose the same environmental threat. On the other hand, benzene is not used as a solvent because it's highly toxic, highly flammable, limited solubility, and can cause ground-level ozone formation. In summary, ethanol is chosen as the solvent instead of benzene to synthesize glycerol and is in line with less hazardous chemical synthesis principle.
Is Masturina Melissa, and I will represent to you about the 4th and 5th principle from the 12th principle of green chemistry. So here we go. So first, about the 4th principle chemistry, which is the safer chemicals and product, which means we have to change the chemicals and product of deodorant to be a safer solution. So basically, we have 3 points in it, which we see in substances and also the cases of the products. So second, we change the chemicals of propyl glycol to lauric acid. Why? Because propyl glycol will derive and create the waste of the substances and also the product. So we don't want to make those anyways. So we change to the lauric acid, which is not creating so much waste as propyl glycol. So third, we change the case of the deodorant from the aluminum or maybe a plastic to the more biodegradable products such as paper and also others. So in deodorant normally consists aluminum zirconium, which is function to clog our pores from creating the sweat. So our armpits will not create the odor smell or maybe a not good smell. So basically, our aluminum zirconium will irritate our skin and also cause the skin cancer in a long term. So we change the aluminum zirconium to the baking soda, which is eco-friendly and also skin-friendly. Okay, we proceed to the 5th principle, which is a safer solution and reaction, which means we have to change the solution and to change the reaction to be more safer than the previous one. So in deodorant, the main solution in it is the aluminum. So as we know, the aluminum is such as the reactive metal that we react to oxygen and create the aluminum oxide, which is the metal oxide, then can irritate our skin. So make the skin more dull or maybe a more pigmented from the previous one. So here, that's why we change the aluminium to the baking soda, because baking soda will not react or less react to the outside compared to aluminium, and will not make our skin to be irritated or maybe more pigmented, and yeah, it's skin friendly too. And second, we change the benzene to the ethanol, as the benzene will create the unwanted and harmful chemical reaction and causing the leukemia, which is the one from the blood disease. So the ethanol is more friendly and will not react to make the other blood disease.
Now I will be talking about principle number 6, which is to increase energy efficiency. One way this can be done is to run a reaction under mild temperature and pressure conditions, which also increase safety. In synthesizing Zen deodorant, lower boiling point and lower heat capacity of solvents like ethanol are used. Lower boiling points of solvents enable faster extraction kinetics, while lower heat capacities cause less energy required for heating or cooling. Ethanol also has high solubility power and high solvent recovery, which further reduce energy usage and increase energy efficiency.
Hey, it's me again, Siti, and I'll be talking about the 7th principle of green chemistry, which is use renewable feedstock. So Zen Natural Deodorants make a bold statement by packaging their deodorants in paper tubes crafted from recycled paperboard. So this choice significantly reduces the demand of virgin materials and minimize the environmental impact associated with traditional packaging. So for your information, paperboard is made from the wood pulp, a renewable feedstock which can lead to the conversion of natural resources. Not to mention, wood pulp is primarily composed of cellulose, which can be converted to levulinic acid. So this conversion not just adds value to renewable resources, but also shows the potential of sustainable feedstock in creating valuable chemical compounds. So let me show you the overview of the chemical process. So firstly, cellulose, usually derived from wood pulp or plant materials, needs to undergo pre-treatment to break down its complex structure. Next, the pre-treated cellulose is then undergoing hydrolysis, a process that breaks down cellulose into its constituent glucose units. This step typically involves the use of acid or enzyme to cleave the glycosidic bond between the glucose molecules. Moreover, the resulting glucose is then dehydrated to form a compound called hydroxymethyl furfural, which is HMF. Dehydration involves the removal of water from the glucose molecules, resulting the formation of HMF, a key intermediate in the process. Last but not least, HMF is further processed through hydrogenation, where hydrogen is added to the molecule, leading to the formation of levulinic acid. So I hope you can bear in mind, by using renewable feedstock, we are able to reduce the dependence on the raw materials, as it is a definite supply and can minimize environmental impact.
Hi everyone, my name is Sarah Akila. Today I am going to talk about the 8th principle of the green principle chemistry, which is to avoid the chemical derivative. In organic chemistry, protecting groups are the temporary modifications added to a specific functional group in order to prevent any undesired reactions that will happen during the multi-step synthesis of a product. These protecting groups will shield the reactive sites and then allow the chemist to manipulate another reactive sites without affecting the other one to facilitate the reactions of the complex compound. So, Zen Deodorant has found another way to replace the propylene glycol with lauric acid and also the anthocyaninic acid, because these are the microbial agents too. But somehow they are not the protecting groups in this product. So, we have followed the 8th principle of the green principle, which is to avoid chemical derivative, which is the protecting groups itself.
Hi guys, it's me again, Ong Kai Bun. I'll be sharing with you about outstanding characteristic of our deodorant product that fulfill the 9 green chemistry, which is the use of catalyst. We have an ingredients in our products called isoamyl laurate. We use rhizopus or lipase as a biocatalyst to mediate the esterifications of isoamyl alcohol with lauric acid to produce the isoamyl laurate in a solvent-free medium because it has the highest performance. Besides that, we have another prominent ingredients in our products called Ozae sativa brand wax. We will use protease, alpha amylase, and cellulase in extracting the rice bran oil to derive into the Ozae sativa brand wax. It has the highest efficiency under the temperature of 65 degrees and pH 7 with continuous shaking at 80 RPM for 18 hours. That's some sharing from me about the implements of green chemistry 9 in our products. Thank you so much.
Hello, I'm Nurul Ashikit, and today I will be explaining how Zen Natural Deodorant aligns with the 10 principle of green chemistry, which is design chemicals and products to degrade after use. This product journey towards sustainability begins with mindful ingredient selection. Zen Natural Deodorant is crafted with a blend of biodegradable and organic certified materials. From Maranta arundinacea root powder to Cocos nucifera oil, each component is thoughtfully chosen to ensure the deodorant is as gentle on the herb as it on your skin. But it doesn't stop there. Zen Natural Deodorant goes beyond natural extract, incorporating biodegradable chemical ingredients like magnesium hydroxide, isoamyl laurate, triethyl citrate, and zinc resinolate. These components not only enhance the deodorant's efficacy, but also break down harmlessly, leaving minimal impact on the environment. Now let's talk about the packaging. Zen Natural Deodorant takes pride in being a plastic-free deodorant. Their commitment to zero waste extends to the packaging, which is made from paper tubes, fully compostable and contributing to a cleaner planet. In conclusion, Zen Natural Deodorant is aligned to the 10 principles of green chemistry by carefully selecting organic, biodegradable ingredients and embracing eco-friendly packaging. Now, moving on to the 11th principle of green chemistry, which is analyzed in real time to prevent pollution. To align with the 11th principle, Zen Natural Deodorant replaced or eliminated the toxic regions with non-toxic regions. As you can see, this product replaces harmful ingredients that have the same purposes with the non-toxic regions specifically sourced from the renewable resources. For instance, instead of utilizing mineral oil for its emollient and moisturizing properties, Zen Natural Deodorant has transitioned to shea butter, which is derived from the nuts of the shea tree. Similarly, the use of silicones has been replaced with Maranta arundinacea root powder to achieve a smooth texture in the deodorant formulation. For the selection of fragrance, instead of using synthetic fragrance which derive from petrochemical sources, they use natural citrus Aurantium bergamia fruit oil for its delightful citrusy scent and Vetiveria zizanoids root oil for an earthy and woody aroma. In essence, Zen Natural Deodorant goes beyond merely keeping you fresh. It embodies a comprehensive commitment to real-time pollution prevention, epitomizing the 11th principle of green chemistry.
Second principle that I will be explaining is minimize potential accident. The production of deodorant consists of petroleum-based chemicals that emit as much air pollution in the form of VOC as motor vehicles do. The VOC will interact with air particles to create ozone that can create asthma and scar the lungs. Besides, the hazardous waste that the production of deodorant is contradicting with the principle of green chemistry as it doesn't minimize potential accident.
Thanks for your attention.
Thank you.